Again, welcome to College Algebra. This is again Unit 6, lecture number 1. In these lectures, we're going to learn how to solve system of linear equations. Again, using substitution method and elimination method. In our next lectures, we're going to learn how to solve the system of linear equation, again, using determinants and also matrix. In these lectures, we're going to focus on only two variables with two equations. So our first step is solve system of linear equation using substitution method. In this case, it will be again two variables with two equations. So here we say we use the following steps to solve system of two equations in two variables by substitution. So the first step, take one of the two equations and you can solve for one of the variable. Let's say in our equation, we have the variable x and y. So I can take the first equation or the second equation, and let's say I will solve for y. Now, when we solve for y and I take the first equation, next I'm going to take the second equation and I'm going to, anywhere I see y, I'm going to substitute the answer I have from the first equation. The answer will include x. Then in this case, I will have only one variable unknown, which is y. So after we solve for y, I'll come back to the first equation and I'll substitute the value of y to solve for x. I think the best way to go through this is, let's see an example. So here we are going to use the substitution method to solve the following system of linear equation with two variables and two equations. So here we have 3x plus y equal to 1. And also we have minus x plus 2y equal to 9. To solve this problem means we need to solve for the value of x and y. Now we are going to use substitution method. Now it's up to us. We can take the first equation and solve for x. Then we take the second equation and solve for y. Or we can take the second equation, solve for x or y, then take the second equation, solve for x or y. So here we decided to take the first equation. Then we are going to solve for y. So 3x plus y equal to 1. So this means y equal to 1 minus 3x. And that's what we have here. 3x plus y equal to 1. So y will give me 1 minus 3x. Now I'm going to substitute 1 minus 3x in the second equation. Now I use the first equation to find y. So I have to use the second equation now to find x. Now, if I use the second equation to find y, then I have to use the first equation to find x. So we use the first equation, we get y. Y gives us 1 minus 3x. So here you can see we substitute 1 minus 3x for y, because y equal to 1 minus 3x. So we are going to substitute it here. So we get minus x plus 2, 1 minus 3x. Remember, 1 minus 3x is y, so we substitute it. So in this case, we can see our equation, we have only x variable that is unknown. So if we have only one variable unknown, then we can be able to solve our equation. So first we open the parentheses, 2 times 1 is 2, 2 times minus 3x will give me minus 6x. Then I can combine the like term, which is minus x plus minus 6x, and that will give me minus 7x. Now, plus 2, when plus 2 cross the equal sign, it will change to minus 2. So 9 minus 2 will give me 7. So I'll divide both sides of the equation by 7. In this case, it will be negative 7 because I need the value of x. So negative 7x divided by negative 7 will give me x, and 7 divided by negative 7 will give me negative 1. So this means x value is equal to negative 1. But remember our first equation, y equal to 1 minus 3x. So now we know the value of x. We can substitute x for the first equation, and we can find the value of y. So y equal to 1 minus 3x. So 1 minus 3x is minus 1. So that gives us 1 plus 3, and our answer will be 4. So the solution will be minus 1 and 4. The first value is the x value. The second value will always be the y value. Now let's try solving the systems using elimination method. So using elimination method means we are going to multiply the first equation or the second equation with any value that will make it possible that when we combine the two equations together, that's when we had the two equations together, one of the variables will be eliminated. So that's why it's called elimination method. So for example, here we say the substitution method for solving a system of equation can be difficult to use if none of the variables has a coefficient of 1 or -1. But fortunately, we can also solve systems like this one using an easier method called the elimination method. So as with substitution, the elimination method will combine the equations of a system to eliminate one term. Or here we say eliminate the terms involve one of the variables. So the elimination method is also known as addition method because we're going to combine the two terms. So I think the best way is for us to see an example. Before that, let's look at the strategy. So first we write the equation of the system in general form. When we say general form, for example, if I have 2x plus y equal to 10, that's in general form. Or if we say y equal to 2x plus 1, that is not a general form. So a general form means all the variables and the coefficient will be on the left side of the equal sign, and only the constant value will be at the right side of the equal sign. So we write the equation of the system in general form so that the terms with the same variables will be aligned vertically. Again, we shall see example what we mean by this. Then next, we multiply all the terms of one or both of the equation by constants chosen to make the coefficient of x or y differ only in sign. What we mean here is that we multiply the first equation or the second equation by any constant value so that, for example, if the first equation 2x, we have 2x, then the second equation should be minus 2x. So that when we combine, they will cancel each other. So combine means we had the equation. So when we had the equation, one of the terms should be, again, eliminated. Then we can solve for the other term. Then later we can use substitution to solve for the other equation. In this case, we can pick any of the two variables, the two equations to solve it. So I think the best way is, let's see an example that will work for us. So here, for example, they say use the elimination method to solve 3x plus 2y equal to 8 and 2x minus 5y equal to 18. Here they say we should use elimination method. So if I want to eliminate x, I'm going to multiply the first equation by -2. Then I'll multiply the second equation by +3, which means I will get -2 times 3 will be -6x. Then +3 times 2x will be +6x. So +6x and -6x will cancel when I combine the two terms, the two equations. Then in this case, we can solve for y. Or in this case, we decided to take, again, it doesn't matter, we can take x out first, or we can take y out. Here we decided to eliminate y first. So in order to eliminate y, I will multiply the first equation by +5, and I'll multiply the second equation by +2. So I'll get +10y and -10y. So they will cancel each other. So that's what we said here. To eliminate y, we multiply the terms of the first equation by +5 and the terms of the second equation by +2. Now, to obtain an equivalent system in which the coefficient of y differ only in the sign, because we have plus and minus already, so we don't need to worry. Now, if I want to take s out, I have to multiply the first equation either by -2, then the second equation by +2, or multiply the first equation by +2 and the down equation by -3, because the signs have to be opposite in order to cancel when you add them together. Here, the signs are already opposite, so we don't multiply the first equation by +5, second equation by +2, we get +10y minus 10y. So this is what we get. Again, when we are multiplying, we have to multiply with all the terms. So I'll multiply the first equation by 5, So I'm going to get 5 times 3 will give me 15x. 5 times 2 will give me 10y. 5 times 8 will give me 40. Then second equation, we are going to multiply by 2. So we say 2 times 2x will be 4x. 2 times minus 5 will be minus 10y. 2 times 18 will be 36. Then we combine. So 15x plus 4x will give me 19x. Plus 10y minus 10y will give me 0. So they will cancel. Then 40 plus 36 will give me 76. So S will give me, I'll divide both sides of the equation by 19 because I'm looking for x. So 76 divided by 19 will give me 4. So finally our S value will give us 4. Now I can use substitution. You can take the first equation or the second equation. So here we decided to take the first equation, which is 3x plus 2y equal to 8. We know the x value, we substitute x for 4, so we can be able to solve y. So that's what we have here, 3x plus 2y equal to 8. X is 4. So we get 12 plus 2y equal to 8. And then 12 will cross the equal sign, be minus 12. So minus 12 plus 8 will give me minus 4. Divide both equations by 2, so y will give me minus 2. So our solution will be 4 for x and minus 2 for y. So here also we say solve the system of linear equation. The same question here. Now we say because the coefficient of y differ only in sign, you can eliminate y terms by adding the two equations. So here you can see that the fastest way to solve this equation is because the first equation we have plus 2y, the second equation we have minus 2y. So we don't need to multiply by anything. We can just go ahead straight and combine. So we combine the equation, 3 plus 5 will give me 8x. Now we have plus 2y minus 2y will cancel. Then 4 plus 8 will give me 12. Now I will divide both sides of the equation by 8 to get the value of x. So 12 divided by 8 will give me 3 by 2. Okay, so we know the value of x. Now I can take either equation 1 or equation 2 and solve for the value of y. So here we decided to take equation 1. We substitute x, which is 3 by 2, plus 2y equal to 4. So here we are going to get 3 times 3, 9 over 2. And 9 over 2 cross the 9 over 2 cross the equal sign to be 4 minus 9 over 2. The answer we get, we divide everything by 2, and it will give us negative 1 over 4. So the solution will be 3 by 2 for x and negative 1 by 4 for, again, y. Now, if you want to make sure your answer is correct, when you get the value of x and y, you can come back to the original equation and substitute the value of x and y. You will get the same value as 4. If you substitute the second equation, you get 8 equal to 8 or 4 equal to 4. If you don't get it, that means the solution again is wrong. The answer is wrong. So that's what we're doing here. We are checking our answer. We know the value of x, we know the value of y, so we substitute. You can see that here we get 4. So 4 equal to 4. Take the second equation, we will get 8 because 16 divided by 2 is 8. So 8 equal to 8 also. So next, let's solve the system with infinitely many solutions. So here they say we should use the elimination method to solve this problem. But you can see that here we are going to get infinity, which means normally infinity will happen when the first equation is the same as the second equation. Look at the first equation. We have x plus 2y equal to 3. If we multiply 2 by the first equation, we will get the second equation. So it's the same. The two equations are the same. So even if we use the elimination method, for example, here we decided to use the elimination method to take x out. So we are going to multiply the first equation by negative 2. Multiply the second equation by 1. So we get minus 2x minus 4y equal to minus 6. Now, when you combine the two, what happened? Minus 2x cancel minus 2x, but also what? Minus 4y will cancel plus 4y, and also minus 6 cancel 6. So anytime you do elimination method and you have 0 equal to 0, it means we have infinity many solution. If we plot these two graphs, we will get a straight line on each other. So that means there's a lot of intersection, so infinity. Now here we say that since the second equation in the original system is twice the first, the equations are equivalent. Now, if we were to solve this system by graphing, the two lines will coincide. That means it will be the same line. They are all going to be on each other. So the x and y coordinate of the points on the one line form the infinity set of solutions to the given system. So here we say the system is consistent. The only thing, it has a lot of solution. So here we say, but the equation are dependent. Infinity solution. Now, next, to find a general solution, we can solve either equation of the system for y. Now, if we solve the first equation for y, we obtain this. So I have s plus 2y equal to 3. So s will cross the equal sign, become minus, so we get 3 minus x. We divide the equation by 2, both left and right side, so that we get the value of y. So our answer will be 3 minus x divided by 2. So now we say that all ordered pairs that our solution will have the following form. If s is 1, y will be 3 minus 1 over 2. If s is 2, y will be 3 minus 2 over 2. So next, let's solve inconsistency. So the previous example, we have infinity solution. The two equations are the same. So we have many solutions. So the equation is consistent. Now, when you have inconsistent system, it means, again, there's no solution. There's no solution. So here they say we should use the elimination method to solve the following problem. We have s plus y equal to 3, s plus y equal to 2. Now we can multiply both sides of the equation by -1 and add it. So I multiply the second equation by -1. And when I combine, I was able to cancel the x. X is cancelled because s minus x. Y also we're able to cancel because we get plus y minus y. But we have a constant value. Now, if we have 0 equal to 0, then we have infinity solution and the equation is consistent. The only thing, the two equations are the same. Here, the equations are not the same, but no solution, so inconsistent system. So here we write the system has no solution. Again, previously we have 0 equal to 0, which means the system have many solutions. A unique solution means we have one value for x, one value for y. If we plot the two lines of the equations, the system of linear equation, we will get only one intersection, which is a unique solution. Many solution means the two equations are the same, so we get the straight line on each other, they coincide. Then inconsistent means there's no solution. If you plot these two lines, they will never intercept. There will be no intersection. Infinity solution means you have multiple intersections. Unique solution means only one intersection. And no solution means, again, there's no intersection. So here they say, if we graph each equation in this system, the graph will be para. Again, para means they can never intercept. And normally when you have two lines that are para, it means their slope also are the same. So the system is inconsistent and the equations are independent. If we have infinity solutions, the equation will be dependent. So this example given to us to recognize graph of a linear equation. So let's say we have a first equation here, A, which is 2s minus 3y equal to 3, minus 4s plus 6y equal to 6. We have B and C. We want to know which of these three equations represent those three possible solutions. So here they say we should match each its system of linear equation ABC with its graph 1, 2, and 3. So begin by writing each system of equation in a slope-intercept form. As we said earlier, if the slope are the same, then the line is para. If the slope are different, then we got intercept. So if we are different, then we have a unique one intercept. So let's see the solution here. So we take the first graph and let's go back. We can see our graph here. This is in general form, so we change both to intercept. This means we have to look for the value of y for both of them. So write it in a slope-intercept form. So find the y value. I find the second y value. Oh, okay. We can see here the slope are the same. So here we say the graph of system A is a pair of parallel lines. If the slope are the same, then we have inconsistent. Remember, the line will be parallel. But if like we have 2/3 x plus 1 plus 1, the equations are the same. If the equations are the same, means we get infinity solution. So let's look at the second one. Second one also the same thing. We come up with a point slope for both of them. We have y equal to 2/3 x minus 1. The second y equal to -½ x plus 5/2. So here we can see the slope are different. So this means actually we have the solution in the previous slide. And the graph of B is a pair of intersecting lines. The lines have one point of intersection. So the system has exactly one solution. And we can see from there the slope are different, the graph is different, the graph are not the same. We only get infinity solution if the equations are the same, which means the slope will be the same, the intercept will be the same. So let's look at the third one. That's what happened in the third one. We can see the third one, we have the slope is the same, but the intercept also -1, -1. So this will give, this is consistent with infinity many points of intersection. The two graphs are the same. Now the first time we have 2/3 x plus 1 and 2/3 x minus 1, which means the graph are not the same, but the slope are the same. So we're going to get a parallel line, which means there's no solution. Inconsistent. This is consistent because they are all the same. And the unique one is the slope are not the same and also the graph are not the same. So in this case, you get only one solution. So that will be the conclusion for these lectures. Again, in these lectures, we learn how to solve system of linear equation using both substitution method and also elimination. And we discuss about, again, 3 different solutions we can get with system of linear equation. That means when we have only one solution, there'll be only one intercept, one value for x and y, which means the slope, again, are not the same. And also the equation, the two equations are not the same. Now we can get infinity solution, which means the two equations are the same. Or we are not going to get no solution, which means the slope are the same, but the equations are not the same. So that will be the conclusion. Again, if you have any question, feel free to send an email, or we will have a class hopefully online on Monday. Thank you.